All right, let's do some more examples here. So here's example 1C. We want to find the radius and the interval of convergence for this series going from 1 to infinity of k factorial x to the k. Now, what's my A? What's my center? Yes, my center is still 0 because this x is by itself, right? If I'm looking at my formula over here, I have c sub k x minus a to the k. This a, if there isn't one, is always going to be 0. All right, and I see that this is a factorial. Yes, so now we're going to use that ratio test. You guys are on it. I love it. So I have the limit as k approaches infinity of the absolute value here of k plus 1 factorial x to the k plus 1. Now this one, because it's not a fraction to begin with, I can just straight up divide it by what we have. All right, then break those up. I have k plus 1 times k factorial x to the k times x over k factorial x to the k. Honestly, well, no, I'm going to show you this here in just a second. These x to the k's go. The k factorials obviously go. Now here, if you guys want to do this, I'm super on board with it. I'm going to highlight it and then I'm going to take them off because I don't want to upload it in your notes. But if you can look at this and say, okay, this is x to the k, and it takes out that exponent, so all I have left is x, right? Because I know that this is just going to be x to that first power, so that's just an x left over, and we can see that happening here. Also, if you want to say, okay, this k takes out that factorial, then because I know whenever I split those up, then the k factorials go, and I'm just left with this k plus 1. If you want to do that with those highlighters, like what I have highlighted, and skip this step, I'm okay. If it helps you to write out that step at this point, that's fine too. But I just wanted to make sure you realize that was totally legit to skip this kind of stuff out, because you can kind of just work that stuff in your head to break that up. Okay, so you have the limit as k approaches infinity now of k plus 1 times x. Now what happens when k goes to infinity? Yes, this whole thing goes to infinity, and I know infinity is greater than 1. So what criteria for the ratio test, if it's greater than 1, what happens? Yep. Then if this diverges, remember we had 3 criteria for a power series convergence. This one diverges. So this only, let me bring it back down here so we can see the whole thing. If I'm looking at my interval, I'm right here at A. So this only converges at A. So what is my radius of convergence? 0, right? Therefore, R is equal to 0, and this only converges at A. In this instance, A was equal to 0 if it was equal to something else. And in this problem, it's legit to say, oh, this could be like -3 here, because that's not really going to affect anything, right? I'm still going to cancel out everything that I cancel out. This would be -3 that I have. Well, big whoop, right? My A here, instead of being a 0, would end up being that 3, and then my A would be a 3 here. Right? It doesn't matter what the center is. This one happens to be 0. I'm going to get rid of these reds with that 3 so it's not confusing. This one happens to be 0, but I'm just saying the center could be anything else. The purpose of this right here is the fact that that's my center, not 0 in particular. My radius is equal to 0 because I'm not going anywhere. I'm staying on this point. So I'm not going out from that point at all. All right, so my 3 scenarios: infinite, on an interval, and just at the point. Okay, so let's do an extra page. because I don't want to limit myself here. Let's do another example. Let's do example 2 here. We want to find the radius and interval of convergence of this series. K is going from 1 to infinity of x minus 2 to the k over the square root of k. All right. It's a nice little power series. What's my a value? Good. All right. So which test do we want to do? Yeah, I would go for the root test also. There's no factorial in here. I'm working this out. I think the root test is going to be our best bet. I want to try to put a k plus 1 in that. Ugh. Okay, so let's go for the root test. So I'm going to take my limit here as k approaches infinity of x minus 2 to the k over, I'm going to write this as k to the 1/2 just because it's easier. I take my limit as k approaches infinity, and do you see this is going to end up with x minus 2 over k to the 1 over 2k? Do you see that? So these two together, when I put those, I get power to a power you multiply, and that's 1 over 2k. All right, now the limit as k approaches infinity. So here's another thing to remember. Remember, the limit as k approaches infinity of k to the 1 over k, what does that equal? Do you remember that? That always equaled 1. Yes. So if you remember that little tidbit, I'm going to rewrite this just a little bit, so hopefully this will be more obvious. I have the limit as k approaches infinity of x minus 2 k to the 1 over k, and then that's to the 1/2 power. So this k to the 1 over k right here is that part. So I'm going to take that off. This whole thing in the denominator, I'm going to make this skinnier again. I feel like it's, I feel like it's too big. Let's take it at least down to there. This whole thing goes to 1. Because k to the 1 over k is 1, 1 to the 1/2. So now I'm left with x minus 2. We have an x left. So what does that mean? Yep, we're going to have an interval. So when you take your ratio test or your root test and you still have that x left over, then you get to have an interval. Sweet. So this has to be less than 1, and I know I'm doing this because this is what meets criteria for which test are we using? Root test. Right? Okay, so set it up. Do we right now know our radius of convergence? You betcha. This is R. Now let's do work. Figure out what is that interval. I've got -1 is less than x minus 2, which is less than 1. Add 2 to both sides. -1 plus 2 is 1. 2 plus 1 is 3. Right? Now check the endpoints. So I know that I've got this interval here from 1 to 3, and my radius of convergence is 1, which is cool because we also know my center here is 2. This is plus r, this is minus r. The question is, what's happening at those intervals? I'm going to scoot it up a little bit. Remember that x minus 2 to the k there, because we're going to be plugging it in. Now, if I'm checking x is equal to 1, plug that back into your original. K goes from 1 to infinity of 1, minus 2. Let me make that nicer. 1 minus 2 to the k over the square root of k. So this is now -1 to the k over the square root of k. So absolute convergence implies convergence, right? So if I take the absolute value of this, then that's going to give me 1 over the square root of k. And that's a p-series. If p is 1/2, which is obviously less than 1, yep, that's a diverge because that's the p-series criteria, right? Well, this is, remember how we talked, if I have this absolute convergence implies convergence, but it didn't, it diverged. So because it diverged, now I have to use the alternating series test to determine if it is conditional convergence, right? So with my alternating series test, criteria number 1 is this decreasing. Yup. Because my denominator grows faster than my numerator, looking if this is decreasing. Criteria number 2, does my limit equal 0? That's the question. Let's put it in here. The limit of 1 over the square root of k equals 0. So yes, both of those criteria are met. So I know that this converges conditionally. Meaning that it is still converges, and then this is a bracket. Ooh, cool. Last time we just had 2 parentheses. It's fun. We've got a bracket this time. All right, let's check the other endpoint, see what happens. I am going to go from 1 to infinity of 3 minus 2 to the k over the square root of k, which then gives me 1 over the square root of k. Well, 1 to the k, right? We were just at this deal. So I know that my p is equal to 1/2, which is less than 1. So then this diverges by the p-series. So this one is a parenthesis. So that tells me my parenthesis goes here on the 3, and I have a bracket here on the 1. My radius of convergence is 1, and my interval of convergence is bracket 1 to 3 parenthesis. So this is what I'm saying. You're not guaranteed one way or the other, right? So it's bracket parenthesis, or, you could always write it as 1 is less than or, oh my, simmer down there, is less than or equal, oopsie daisy, but 3 is just less than. All right? Okay. Good. That makes sense? So just, if you have that X in there, so to recap, let's go back up here, and then I got one more example to do, but I want to recap this up here first. Since we've gone through this, then let's talk about some things that we're looking at. For this one, up here, this is, you take the ratio or the root test, and there's no more X's. No more, nothing that can, I actually take that limit, and the limit comes up with something that's going to make my statement true no matter what the X is, right? It's always going to be true. That's absolute convergence. If I come up with this, I don't have any more K's. I only have X's in my answer. If there's no more K's, all the K's are gone, there's only X's in the answer, that's when you split that up, and then you have to test those endpoints. If it diverges, so these two, 1 and 3, you stop after you do the ratio or root test. So you do that ratio or root test, and then you're done. You stop, because it's either converges absolutely or it diverges at the ratio or root test, meaning that it only converges at that point. You have more work to do if you have to do the interval. All right? Okay.